Okay, I think we're going chapter 10, properties of circles. First thing we'll go through are just some definitions. Some of these are things we'll already know about circles. Some of them might be new. Okay, so pay attention if it's something we know. Just kind of reiterate that, go back and revisit that, and make sure we understand what we're talking about. First of all, we've got to define a circle. What's a circle? How would you define a circle? Or what would you say, what do you know about it? It's a round, okay?
It rolls.
It has no sides. A circle rolls.
And it's like a tire.
Okay, if it's made into a tire, sure. It could potentially roll. How would you define it? A definition has to be, a rigorous, good definition that always works. What? A sphere. Okay, a circle and a sphere are two different. We'll come back to a sphere later on, right? A sphere is a three-dimensional object. A circle is flat. Circle just has one dimension, it's flat. So we'll define it as the set of all points. So a circle is kind of like a line. Remember when we talked about a line is really a whole bunch of points. A circle is really a whole bunch of points that are all what? What characteristics do we have all of these points that make up a circle? They're all the same distance from where? The center point. They're all, the radius is that distance. They're all the same distance, or in math or geometry we call that equidistant. They're all equidistant from the center point, right? They're all equidistant from a center point. Okay. And that distance, so here's our circle. Circle is made up of a whole bunch of points. Every point on this circle, no matter where you're at, it's always the same distance from the center. And so this distance from the center of the circle to the circle is what we call the radius, or we'll call that r. So it's the distance from the center to the circle. When we talk about the circle, we're talking about all of these points. So we go from the center to the circle, that is a radius. And we abbreviate it r. I think we should be familiar with that. Something that might be new, a chord. What's a chord? Some of you are in music class, you might have another definition for a chord, right? A Honda is also a chord and a chord, but that's not what this is. This is a chord. A chord is a segment, or a line segment. Remember, if we just say segment, we imply that it's a line segment, which is a part of a line or a piece of a line that has endpoints on the circle. Endpoints on the circle. So this would be a chord, right? It's a piece of a line, it's a segment, and the endpoints of that segment are on the circle. So this would be a chord. Okay. Next one's diameter. That's probably something we know about. What's a diameter? All the way around. No, that's not diameter. Distance all the way around is perimeter, but on a circle we call it circumference.
How is it from like one side to the other?
Okay, the diameter is from one side to the other, so it is a chord. It's still a chord. By definition, it is a chord. Diameter is a chord that passes through, specifically, it has to go through where? No. The center. Okay, that's your center point. So this, it's a chord. Endpoints are on the circle, and it passes through the center. So this is your diameter. And we abbreviate that D. That's fine. I think you're familiar with that. So that's the diameter. We'll finish with a chord that passes through the center. Okay? A secant. That's a new one probably for most of us. What's a secant? Okay? So this is a chord, a radius, a diameter. We come over here. This one is going to be a secant. A secant is a line. Notice, right? It's not a segment. It has arrows. It goes on forever in both directions. So it's a line that intersects the circle, or that passes through the circle. We call that intersects. intersects the circle, how many points? 2. If it's a secant, you're going to cross through the circle and you're going to touch it twice. So this is at 2 points. So you have a secant there. I mean, you could draw, any line that passes through the circle and touches it twice is a secant. Okay. Then one more is tangent. Now we've talked about tangent as far as a trig definition of tangent. There is a relationship, but we're talking about a tangent line or tangent to a circle. Think of it, it's a little bit different. There is a relationship, and it's more complicated. If you go on and study math, you maybe run into that. Or if you really want to know, I'm sure you could Google it, look at the relationship between a tangent line and the trig definition for tangent. Is kind of interesting. Tangent, though, as we talk about a tangent line, it's going to be a line again, right? It has arrows, it goes on. So it's a tangent line that what? Touches or intersects. We'll say, right, crosses or intersects the circle. And how many points, though? At exactly 1 point. So it's a line that intersects the circle in exactly 1 point. Right? So this one here is a secant. We just did that. This one down here, notice this line comes by and it just touches the circle at exactly one spot. Right? If you have a circle, it's that curve, and you have a line that's straight, you can draw the line so it just touches once. And if that happens, this is a tangent line. Okay, so that's the important thing. Tangent only touches once. A secant would go through the circle and touch it twice. Questions on any of that? Tangent, secant, chord, radius, diameter, circle. Okay. We're going to look at the intersection of circles, coplanar circles. Okay, we can talk about different ways that circles can intersect, or the different ways that circles can cross, or cross over each other, or touch each other. So we can have 2 points of intersection. So what would that picture look like if I had a circle that crosses at 2 points? 2 circles, like intersection of coplanar circles. So we have 2 circles. So there's a circle. If I'm going to draw another circle that's going to cross it in 2 points, it's just going to overlap. Yeah, it'll look like a Venn diagram if you want, right? And it crosses here and here. So they touch at 2 points. They intersect at 2 points. Can I draw 2 circles that intersect at 1 point? Okay, these would also be called tangent circles if they only touch at 1 point. So I could draw a circle. How would I draw the next one? Where we just touch just once, right? So we could draw like a snowman or something. You just touch at exactly 1 point right there. Okay. Is there any other way to do this? You could put one on the inside, right? This is how it would be tangent on the outside. I could draw a circle, and then I could have another circle just touch it once on the inside. That would also be a tangent circles. 2 circles that touch at exactly 1 spot. And of course, we could have circles that don't intersect, or that do not intersect. What would that look like? Okay, 2 separate circles. Okay. Is there any other way you can have 2 circles that will not intersect? You could have one inside the other, right? And you could also, there's a special type. What if we have 2 of them inside of each other, and they both have the same center? There's kind of a special name. This is called, anybody know what that's called? Okay, if these 2 circles have the same center, these are what we call concentric circles. And they share the same center. Concentric circles share the same center point. Okay. So that means they're always exactly the same distance from each other, right? So every point on the circle is exactly the same distance from each other. You could also have two circles that were not concentric and one be inside of the other. That would be fine as well. Okay? And so if you really want to have fun, you can maybe make that into a little picture. Smiley face. A little big or something. All right, a line or array or segment that is tangent to two coplanar circles is called, right? Well, we already talked about a line that is tangent to one circle. If it's tangent to two circles, it's called a common tangent. A common tangent. So how could you have a picture of a common tangent? Well, you'd have two circles, right? So we have to draw two circles. I can draw a circle and another circle. Can I draw a line that's tangent to both of those circles?
Yeah.
What would that mean? If it's tangent, it means it does what? Just touches them once. So I can draw a tangent line that's just going to touch this circle once and just touch that circle once. That would be a common tangent. Okay. Now, if you have two circles, you could also draw a common tangent that comes across here in the middle and just touches there and sort of, I didn't draw it quite right. Just touches there once and touches here once. Yeah. So there's another way you could draw a common tangent. Similarly, right, I could draw one across, across the bottom here that just touches both of those. You draw another one across here that just touches both of those. Questions on that? Okay. Moving on. We can use the diagram here to answer some questions. So in geometry, like we've done before, you can graph things. You can put them on the XY coordinate plane, which is nice. Gives you a nice little graph. Okay. And you can use those graphs to measure, to count the distances between points. And so you can go through and answer questions about the radius or the diameter, so you just have to be careful and think carefully about what it is that they're asked. So if they say the radius of circle B, okay, so you got to look at circle B. Which one is circle B, the big one or the little one? Which one? The little one, right? Because it's the same distance away from B. So it's 2, 2, 2, 2. So it's got to be the little circle of circle B. Does everybody see that? So what's the radius of circle B? What are we talking about when we mean radius? From the center to the circle. So you go from the center out to the circle. How far is that? 2. That's 2, that's 2, that's 2. Right? So it's 2 in every direction, so the radius is 2. What's the diameter of circle A? Now we just changed, two things changed, right? Now we're talking about diameter, which is different, and we're talking about the other circle, circle A. So which circle A is a big circle? So what's the diameter? Diameter means distance all the way across through the center. So the diameter is going to be 6. Exactly. What's the radius of circle A? Half of the diameter. We already know the diameter was 6. Half of that is going to be 3. Or you can look at the picture and count. 1, 2, 3. What's the diameter of circle B? 4. Diameter is going to be 2 times the radius. Or you can go back to the circle and count. How far is it across? How many common tangents do these circles have? And then draw them in. So we have two circles that are overlapping. So these two circles touch, or they intersect twice. How many tangents can we draw? Common tangents. So it's got to be tangent to this circle and tangent to this circle. So I could draw one across here, right? Imagine that's a straight line. Okay, where it just touches once here and once there. Any other tangents I could draw? Across the bottom, kind of the same general area here, across here once, and touch here once. Can I draw any other common tangents? Okay, no, right? I can draw a tangent to this circle, but it's not, right? You can draw a line that just touches this circle, but it's not also tangent to the other one, so that wouldn't be a common tangent. So there's only two, right? How many? Two. If I have two circles that are not touching, how many could I draw? Four. I have these same two that you imagine, right? Going across the top here, across the bottom here. Plus, I also have what? The two that cross through the middle, right? Those are just going to come in here and touch once there and once there, once there and once there. That, imagine that only touches once. Okay, so we'd have four common tangents. And the last one, where I have two circles that just touch at one spot, how many common tangents do I have? Well, I have these two that are kind of like the first one, obviously. That'll come by and just touch here and touch here. And there would be one in the middle, exactly. So there's actually three. You can draw a line that goes right down the middle and just touches at that one point, the same point where those two circles touch. So there could be three for this one, three common tangents. Questions on that? All right, now next we'll get into a couple theorems, and these theorems are going to be kind of the basis for some of the problems we'll solve using circles. So the first theorem, 10.1, in a plane, so this just means we're on a flat two-dimensional surface, a line is tangent to a circle. A line is tangent to a circle if and only if, this is an important statement, if and only if the line is perpendicular to a radius of the circle at its endpoint that's on the circle. So the last part, at its endpoint on the circle, that just makes sure that you're talking about the radius and you're at the endpoint that's out here on the circle. So we would say that this line is tangent if and only if it's perpendicular to the radius. Okay? So this is a very interesting property. It's very useful. It's very helpful to calculate lots and lots of different problems. If this line is tangent, you know it's perpendicular to the radius. Or vice versa. That's what if and only if means. You can go both directions. If you know it's perpendicular to the radius, then you know that this line is tangent and it only touches once. Okay, so it goes both ways. Questions on that? Yes. It's always like that, yes. What's that? Confused about? In a plane, that just means we're on a two-dimensional plane. Yep, that's just kind of a generic way to make sure the definition is sound. In a plane, so we're on a flat two-dimensional surface, that means this line is not going to be going out of the board or something like that, right? This line is on the same plane as the circle. They're both on this sheet of paper. Does that make sense? Then these will always be perpendicular. Okay? And the one more theorem, 10.2 says tangent segments. So now I have two tangent segments. Now that just means, right, tangent segment, that's just a piece of a segment, or a piece of a tangent line. You imagine these lines would go on forever, but it makes the picture a little bit more messy. So they just took a piece of that tangent line, made it a tangent segment. And if these two segments are from a common point, common external point, so this word should be external. A common external point, which just means outside of the circle. Common external point are, what do we know about what do we notice, or what do you think about these two tangent segments from a common external point are going to be what? They're going to be congruent. They're the same length. This segment and this one, they're from the same point that's outside the circle. When you draw them to the circle and you're tangent, that means you're just going to touch at one point and touch at one point. This piece and this piece are congruent. And that will always be true as well. Okay? So, two theorems. Okay? Study these, make sure you understand, make sure you know them. Then we go through and solve some problems. You'll use these theorems in order to help you solve the problem. Example. In the diagram, segment AB is a radius of circle A. Is segment BC tangent to circle A? So they're telling you, we know that this is a radius. Right? That's a radius. You can see that. And that's 25. And then the question is this segment BC, so from here to here, is this tangent? So what are they asking, in other words? If we knew it was tangent, what else would we know? It would be perpendicular, exactly. If this is a tangent, it has to be perpendicular. Do we know if that's perpendicular? That's the question. In other words, they could also said, right, is it perpendicular to the radius? That would be the exact same question. Can we answer that question? If I have, what do I have sitting right here? Something with three sides. It's a triangle, right? Even though we passed the chapter that we dealt with triangles, do they ever really go away? No. What do we know about triangles and their sides? If it is a right angle, what do we know these sides have to do what? They have to do what?
Equal to 90?
Not the sides.
Oh,
They would have to fit Pythagorean theorem. So our question is this a right angle? I don't know. If it is a right angle, it has to fit Pythagorean theorem, which would say a squared plus b squared equals c squared. If it is true, that tells us it's a right angle. If it's not true, then we'd say no, that's not tangent. That's not a right angle, so that line's not tangent. So what do we plug in for A? 25 squared. What is B? 60 squared. C has to be 67. Okay, 25 squared plus 60 squared. Anybody have an answer for that? What is it? 4225. What's 67 squared? Ooh, 4489. Are those equal? They're close, but does that count? Only in hand grenades and horseshoes, right? You heard that? Close only counts in hand grenades and horseshoes. Anyway, this is not equal, so what's that mean? This is not a right angle, so that means these are not tangent. So the question, is this tangent? No. Does that make sense? How do we define if it's tangent? Well, we just got to check, is this a right angle? Is it perpendicular to the radius? Next question, in this circle, segment DA is tangent. So D to A is a tangent. And segment D to B is tangent. So these are both tangent. Find the value of x. If those are both tangent, what does that mean? What's our theorem tell us? These two pieces are congruent. So how do we solve for x? Write an equation. We've probably done this a million times, right? This one equals this one. 6x minus 8 equals 25. And we solve it for x, or so we're trying to find the value of x. So what do we do first? Add 8 on both sides. 25 plus 8 is what? 33. And then what do we do? Divide by 6. We get x is equal to 5.5. Approximately or exactly? Exactly. Nice. What? Questions on that? Okay. Next one. Okay, and here we're given segment SR is tangent to the circle. To circle T, find the length ST. Okay, so we have this is 48, and we know that this is tangent. So if that's tangent, what does it mean? It's perpendicular to the radius. So we know that's a right angle right there. Now, we know this is 48. This one is 36. Okay, notice this is not the whole thing. This is just this piece. A little bit tricky here. Okay, what do we know about this piece here and this piece here? They're both what? They're both whatever that radius is. They're congruent. So I don't know what that is. I could call it something. I'd call it R if I want for radius. And this also is R. Does that make sense? So we have a right triangle. We know one side is 48. This side we don't know. We know some of this side, but we don't know the whole thing. But we want to find this piece ST. Right? That's find the length of ST. In other words, we want to find R. So can we write an equation to help us solve for R? What do we say? Pythagorean theorem. You have a right triangle and you have the sides of a right triangle. You would still use Pythagorean theorem. Okay, now pay attention. It's going to be a little bit tricky, a little bit of algebra stuff. Those of you in Algebra 2 shouldn't have too much of a problem handling this. Geometry students, pay attention. You've probably done this at some point, but watch carefully at this example. You'll have to do 1 or 2 on your assignment. So we know Pythagorean theorem is what we're going to use. So a squared plus b squared equals c squared. Now, what do we plug in where?
48 is B.
Okay, so we can call this one B and this one A. So A has to be, we don't know, it's R. So I'll call it R squared. Plus B is 48 squared. So I have 48 squared. C in this case, C is the hypotenuse. Well, that's the distance from here all the way to here. Do I know that distance? No, but I know this part is 36, and I know this piece is R. So this whole thing together has to be what? 36, not 36R, but right, if this was 4, if R was 4, what would this whole thing be? 40. It would be 36 plus 4, right? So in this case, it's just 36 plus R. I don't know what R is, but when I do know R, I can plug it in and figure that out. So in this case, C, what do I have to plug in here? 36 plus R. And that whole thing is being squared. So this is where the algebra comes in. It's a little bit tricky, but we can do it. Okay, on this side, we have R squared plus, anybody calculate 48? 48 squared, 2304. Now, what do we do here when I have 36 plus R squared? What does that really mean? When you square something, you're doing what? You're multiplying by itself. So if I have 36 plus R times another 36 plus R, this really means this. And if you remember from algebra, what do we have to do when we multiply something like that? Distribute, which is, and when you have two binomials, we may have seen this at some point, FOIL. Have you guys heard of that? FOIL. FOIL means first, outside, inside, last. You guys learned that in Algebra 1? FOIL. I think you may have, but you probably forgot. So what we're going to do is FOIL means first. So if you need to write this down, first, outside, inside, last. First, outside, inside, last. So all you're going to do is you're going to multiply. See, we're multiplying this binomial, these two terms times these two. So we'd have to distribute. But we have two things here, so we got to kind of have to distribute twice. Does that make sense? We all know the distributive property, right? You just multiply it by both things. So now we have to distribute 36 times 36 and 36 times R. And then we have to do R times 36 and R times R. So this is where you get FOIL. First, outside, inside, last. So let me write this down again here. 2304 equals. Now, when we multiply, so we're going to multiply the first two numbers. So I have 36, and I'm going to multiply by 36. So somebody with a calculator, what do we get? 4,000. 1,000. That sounds better. 1,000. 296. Yep. So that was first. Then I multiply outside. So I take 36 and I multiply it by R. So I have 36 times R is just 36 times R. 36R. So that's first outside, inside. To take R times 36, which is another 36R. And last, so I got first, outside, inside, then last I take the R, which is the second one, and the R, which is the second one. And when you take R times R, what do you get? R squared. Okay, so that's just algebra, distributive property, multiplying it out. Now we just simplify, we're solving for R. So we need to combine like terms, get everything on one side of the equation, get R by itself. All that good stuff, right? Now, when we combine like terms, remember I can only combine R squared, or X squared if it was an X, with another X squared, or R squared in our case. So I have R squared here. What am I going to do to get it on the other side? Subtract. So I subtract R squared, then I subtract R squared here. What happens? You get what? 0 R squared. Yay! Algebra 2 students, we do not have to solve a quadratic equation, right? Which we wouldn't do in geometry at this point. So you get 0. You shouldn't get R squared or X squared for these problems. And so we're left with 0 here, and then we have 2304, 1296, 36R and 36R. We're combining like terms, so we can put those together. How many R's do we have? 72R. Okay, a couple more steps. What do I do to get R by itself? Subtract 1296. And you get what? 1008 equals 72R. Then what do I do? Divide both sides by 72. And we get R is equal to what? 14. Is that what we wanted to find? Is that our answer? Well, go back and look at the problem. We've done a lot of work. Is that what we wanted to find? Yeah, we wanted the length ST. Well, we defined ST to be R. So that's our answer. That's what we wanted. The radius is 14. Okay, your assignment. I think it's wrote it on the board over there, but I'll write it up one more time. 655, 3 through 24, 27 to 28, and that's all. And I think we'll be done with the recording. So anybody that survived, listened to the whole thing, congratulations. If you guys want to say anything to your other classmates that listen to this later on the website? No? Make fun of... Tell Chrissy a joke, or she said do something funny. All right, well, hopefully they watch it to the end and they can hear our good jokes, but
I bet they don't watch it.
they probably won't watch it, so that's all right. Yep.